Okay, so what we're going to do today is steam nozzle. Alright, so this is the first question in your EST already. Alright, so I already posted up the assignment online for the 20%. That means 20% is a written assignment and two mini quiz. Alright, so I strongly encourage all of you to work together to get it done. That thing is 20%. 20% comes from your lab, total 40%, two of your test, MST and EST, 30% each. That makes up your 100%. So please make sure you can get your 40% in your pocket. Okay, means your two lab, make sure you do properly. Okay, more or less I think all of you are doing fine with your lab. This assignment, please make sure you do and submit on time. Okay, so the deadline is 1 month from now. Alright, so please try to plan your time. Don't after that last minute tell me cannot because it's the time I think is very close to the final week. Alright, so please try to do that for me. Alright. Okay, so check polymer. You all have visited polymer before, right? Don't tell me you don't know polymer until now. Okay, so what I'm going to do today is steam nozzle. So give me about half an hour to of the time, concentration. Okay, so I will run through the theory quickly here. Okay, same thing we always do. Then after that, I will cover the tutorial question here. Alright, so steam nozzle. Basically, it's a device used to convert energy stored as pressure and temperature into kinetic energy. Give me one example of a nozzle in your house. Nozzle. Shower head is one of it. Every little hole there, right? In your shower head, every little hole is 1 little nozzle there. Okay? Then if let's say you all have you used a garden hose before? Then if let's say you want to water something or splash water somewhere, you want to stand here, you want to stand so, don't want to go near, what you do? You pinch the tip of the nozzle, right? Then the thing will go further. So that one is basically a form of nozzle also. Okay? So obviously what we're going to do here is not so common nozzle, not like your home kind of nozzle. The speed here we are talking about is meant for aircraft. Okay, or meant for high pressure application. Alright, so with that said, your jet at the back, this one, you are looking at convergent divergent nozzle. What does convergent mean? Become smaller. Cross-sectional area becomes smaller. Converge. Then diverge this one. Number one. So English, convergent, divergent. So today you are going to learn not just convergent or divergent. You are going to learn the combination. Alright, which you are going to explain. I hope by me explaining today, you will understand why we are using converge to diverge. Okay, that's the key part. Alright. So first we talk about the convergent one. Okay? So when you talk about the convergent one, it means that cross-sectional area here bigger go to smaller. Correct? This one all know. Okay, so based on your knowledge, okay, of common sense, here is go in, here come out. When you go in here, let's say the speed is V1, speed, or you want to put speed, come out. What is the speed, higher or lower? Higher. Oh, careful. Because C2, so C2 higher. Clear? Okay, so these are all agree. Then, now, so this is your area 1, area 2, obviously area 2 higher. Okay, answer. Correct? Area 2 lower. Thank you. I wonder all of you are still feel like start. Area 2 lower, higher. Okay, now, my question is, if you go and measure the static pressure here higher or lower?
Higher, lower.
Higher or lower?
Lower.
Hamtam one or low Y one? Low Y. So you say higher, is it? Okay. This one is correct. Okay, this is wrong. Pressure actually drops. So I'm going to show you what do you want.
I vision
So can
Oh, improve.
So this one is obviously okay, can Okay, so first I'm going to show you why is it like that. Okay, do you know the mathematical reason why is it up? Why speed increase? Because area is smaller. I'll show you the mathematics. Based on mass conservation. Mass conservation tell you what? Mass in equals to mass out, right? Okay? And when mass in equals to mass out, if let's say your what is Q? Heat. Okay. Q you will learn before heat. I don't blame you for that. Here is actually volume flow rate. Density times volume. So this is the meter second. Cannot.
Cannot.
Just now can, now you cannot.
Keep on changing.
Cannot. This is volume flow rate. Now this one, okay? Okay. So let's say volume flow rate equal, because what volume must come out. Initially I put density here. Density times volume give you mass, right? Okay? So if let's say it's water go in, water go out, what about the density? Is it the same? Same. Because water cannot compress. Clear or not? So 1000 here, 1000 here. That's why I say same cancel. Okay? So what you have left is volume equals to volume flow. Okay, start. Now, area times by your velocity. Area times by velocity gives you what? Area times velocity gives you volume flow rate. Understand? Okay, or loss already. Volume, right? If volume flow means this one must be speed, right? And then this one is your area. Okay, okay? Now, so from here, if this one is constant, if your area decrease, what happens to your velocity? Increase. All understand this thing? Okay, this basic you know. Okay. Now I talk about this one. This one is what the second one is actually what Mr. One supposed to teach you on the last two lessons before your ESP. Okay, so I will just show you right now. Okay? So by right there is this formula that looks like that. This is pressure over density, gravity. So pressure over rho g. Okay, this is actually your pressure energy. Then you plus with your velocity over g. So this is actually something like kinetic energy. Alright, this is actually equals to this. Okay, this equation you don't know now. I just show you only. So what is telling you that actually this is the energy in equals to your energy out. So actually it's an energy equation. I will let Mr. One go in very good detail what this means. He will. He will. So I don't talk him. I now go after him. I let him help you after that. So look here. So this energy in because this energy out. All this constant constant, so all removed. Okay, so what happens now? If your velocity or your C, actually it's supposed to be C, velocity. If this is constant, if your C goes up, what will be your P? It must go down. So actually your pressure is dropping, level. Clear enough? So this one, I need you to, later I will show you where in your book, you please highlight it to make sure you remember this. Okay, when you do this question. Okay, then? Alright, so this one take out, very important. Okay, so with that said, this is your conversion nozzle. Okay, and so what we have shown here is this. When your conversion means your area getting smaller, velocity will increase, but pressure will decrease. What I need you to take note is very simple. Velocity and pressure are always opposite. Clear? Huh? So there will be no scenario whereby your pressure and velocity both increase together. Am I clear? The pressure go up and the pressure go down, the velocity confirm go up. All clear this part? Follow? Huh? Anyone got any problem here? Can? Huh? Second thing, what is, have you heard of this word subsonic? Speed. So what does subsonic mean? Below or above or at speed of sound? Below, is subsonic is below speed of sound. Above speed of sound for what? Supersonic. Okay, so I'm going to illustrate this thing. Can I write this? Okay? Okay, so this term here is, you all should know,
Never take out me. Still from yesterday.
Okay, so let's say you're standing here. Okay, you got a building here, above you, this building. Alright, and then you got an aircraft. So, understand the thing, you are standing here, you are looking outwards like that. Plane here, plane now moving at subsonic. This means that the plane is moving faster than sound or below speed of sound? Below. Which means that the sound will propagate faster than the plane. Am I right? Yes. This means that you see the plane first or you hear the plane first? You confirm will hear the plane first because the sound wave will reach you first. Any question? This is the subsonic condition, like even here, is something you can imagine because in your house, most of the things in your house are what? Okay? Nothing in your house, to my knowledge, is supersonic. No tech in your house or what is supersonic tech. Not to my knowledge. Oh, you don't give up.
Then water jet doesn't count.
Water jet, if you talk about HDB, the high pressure one, also not supersonic. But there are applications like this one. This is supersonic one. Okay, more for industry purpose. Okay, so now in this case, let's say we talk about sonic. Means what? Let's say the plane is here. And it runs at sonic. Means what? The speed of the plane and the speed of sound is the same. Whenever that happens for an aircraft, a shock wave is actually created. This is actually called a shock wave. Okay, so what happens is that the sound wave actually gets stuck behind the shock wave. Okay, and so they all just propagate here like that. So this means in this case, you see and you hear same time. Direct same time. Okay, it's same time. If it's sonic, all the sound wave is collected at the back here. It cannot propagate past it. Okay, due to the density change. Okay, this one relatively complicated. You want me to go in greater detail? No, okay. So I will just tell you what you need. So here, propagate, clear up. So that means the plane and the sound wave the same is when you see the plane, you also hear the plane. Clear up? This is your sound. So obviously the most jalak case is that super. So can you guess how a supersonic condition look like? It goes above the speed of sound, alright? And so what happens? That means the aircraft is moving faster than your sound wave. So this now your shock wave from a straight line become a V-shaped line, and all your sound wave are propagated behind it. Clear now? So when this case, when you look up, you will see the plane first. But do you hear the plane? No, you can't hear anything. When will you hear the plane?
Only initial takeoff.
No, when it's flying. So now when it's flying, When will you hear it?
Fly past.
When it fly past and you become inside the V, the shock wave. This means that you have to wait until the plane fly past, maybe quite a distance already, then only you can hear. First part, you must be inside the shock wave, then you can hear it. All clear on the side? Okay, so you can observe this in those what Singapore aerospace or what in the plane where you fly at air show. If there's still going to be an air show based on this kind of scenario. So so for aircraft, if you go and if you are those aviation enthusiasts, you go and look at the aircraft, you will see Mach 1, Mach 2, Mach 3. What does Mach 1 mean?
Is it the speed?
The speed. Mach is the speed. So Mach 1 means what? At the speed of sound. Mach 2 means 2 times the speed of sound. Mach 3, 3 times. Mach 4, 4 times. Okay, so that's how it works. So Mach is actually the velocity over the speed of sound. So if you take about velocity in air, speed of sound in air, about 300 ms meter per second, not kilometer per hour. 300 plus kilometer per hour is the speed of a bullet train, right? But you must take note of this speed of sound is 330 meter per second, not kilometer per hour. That's how much faster it is. Okay, can So this is exactly what I said. Okay, your shock wave will be when you have Mach 1. Then you got your shock wave, supersonic for that. Okay, can I continue? Okay? Alright, so with that said, this is a conversion nozzle. I will explain again. Now, what I need to take note here, I'm not going to go into too much of the details, but what can you observe? If it's subsonic, what happens? I already explained earlier, right? So listen, you must take attention here. When it's subsonic, means below speed of sound, this is what you can imagine. And when you imagine, you can see that when the area goes down, the velocity will go up, and the pressure will always be opposite of the velocity. Okay, Now, if you are supersonic, notice what happens to the velocity. It will actually drop. And this is conversion. So you must understand it's conversion nozzle. But in supersonic mixture, let's say it's at 1.2. Okay, 1.2, let's say at 1.2 here. Come on here, what's the velocity? If come here is Mach 1.2. Here, what's the velocity? Higher or lower? Lower. It will drop. Okay, if it's supersonic, if subsonic means let's say 80 meters per second, come out will be faster. So that's the key thing about supersonic for divergent. It's totally your imagination out the window. It's not something you can feel or imagine anymore. The concept is quite different already. Alright, so take note here. If Mach 1.2 reach here, the speed actually drops. You won't get Mach 2, Mach 3. You will drop down to maybe 0.8. So this subsonic, this company will be subsonic. Are we clear? Yes. Correct. Yeah, because it's supersonic. So when it's supersonic, right, the air compression actually becomes more pronounced. That's why you cannot imagine. Calculation can show. Experiment, if you put the die or what, I think can see. Or simulation can see. But you imagine a bit hard to imagine. That's why I say this one is totally cannot imagine. You can only remember by the velocity is opposite from subsonic. This is what you can imagine. So this is what you cannot imagine. This is opposite it. And remember always again, pressure is always opposite of velocity. This one still remains unchanged. Okay, can or not? Alright. So if you understand this, at least the subsonic part, and you remember this part, the divergent one should be quite straightforward also. So divergent one, okay? I'll show you one divergent one. So divergent means it's getting bigger. For divergent subsonic, when it gets bigger, your velocity will drop. Is that understand right? Must I explain again? No need, huh? So obviously when you go this way, water goes in here, velocity will drop, then pressure will obviously go up. Clear this one? So again, this one can imagine one. This is exactly what you told me earlier. So subsonic will be what? Velocity will go up, this one will go down. So this means what? If here is Mach 1.2, here will be what? 1.4, 1.5. Higher lah. Supersonic here, come out here will be even higher supersonic. All clear? Alright? So that's why if you start to see the picture, you will understand why we have convergent divergent. So what actually happens here? Why do you need this technology? Can you understand what's going on?
Accelerate.
When you put in here, because anyway, let's say take for example an aircraft. Okay, this is an aircraft. So when the air goes in, obviously the air will be slower, right? So it goes in, maybe at subsonic. So in this case, it goes in subsonic. When it enters at subsonic, when it goes through a convergent nozzle, what happens to the speed? Up or down? Up. Speed will increase, correct? So when the speed increases, speed is accelerating. What you need, if you design properly, is that when you hit here, you will hit at Mach 1. So the moment you hit here at Mach 1, when you go to the divergent side, the speed will go up or down? Go up. So when the speed goes up, means it continues to accelerate. Here you will hit Mach 2, Mach 3, whatever, depending on how you design. Up to this point, I give you 1 minute. You observe this. Clear or not? So I'm showing you agar your velocity here close to 0 because it's very slow. Goes in here, hit Mach 1. Then when it continues divergent, you will accelerate to higher speed. Now, so obviously some of you might be thinking what happened if you never hit Mach 1? Then go through what happens? So let's say here never hit Mach 1, here hit maybe only 200 meters per second. Then what happens? It will drop it will drop to 100 or 50. Then does this serve your purpose anymore? You waste money only. You install this, but then it gives you much slower speed. So this means what? When you buy this thing, when you get it for a certain application, you need to make sure you calculate it will accelerate throughout. The throat here, this is what they call the throat, must hit Mach 1. It must hit Mach 1. Follow? Okay? So that brings us to another part. When you hit Mach 1 here, do you think, based on what I just said, can you hit, based on here going to subsonic, come to this point here, hit Mach 1.2? Can it go through here from maybe very slow, accelerate like that, all the way to Mach 1.2 or Mach 2? Can or cannot, you think? Can? You understand my question or not? You all understand or not? I'm saying, if let's say you don't have this part, you just have the convergent part. You put in here a slow speed. Can you accelerate it all until here become above Mach 1?
No.
Obviously not. Because if can, why you need the back part? What's the point of you installing this part? If already this thing can give you higher than Mach 1. So the physical limitation of the system here is that if you don't have this portion here, the maximum you can reach is what? Mach 1 only. You want to go higher than Mach 1, you must install the divergent portion. Are we clear? Okay, so you only got one side, you will maximum die come out only Mach 1. That's what I'm trying to stress here. Can or cannot? Follow? Okay? Anyway, if you don't follow, Make sure you know how to do the math, I mean. Then you know, make sure you know how to calculate that. Okay, so this is actually the graph here. I don't talk about this graph here. Okay, but what you can see, you're not going to see. Okay, so this is the mark. Okay, now I say this is the bigger. So this is the mark number graph. So the mark number is your speed. So basically, for your syllabus, you must get this green line. Not say this green line. You must make sure that your thing will accelerate through. That's our assumption. Do you need to know this graph? No need, you need to draw. Okay, so I'm just showing you here. So I will explain to you what happens if you got to. So obviously, for something to flow through, right, your pressure here must be much lower than your pressure here. Make sense or not? Higher pressure will flow to lower pressure lah. Okay, make sense So this shows you what happens with the back pressure here. Pressure at the back here is not low enough. So obviously, if you, like I said, you accelerate through, never hit Mach 1, obviously the speed will get slower. Right? Makes sense. Alright? And then you got other scenario also, although it hit Mach 1, but the pressure at the back not low enough, you will still go up, almost Mach 1, but it still decelerate. So what you must have, your pressure must definitely be low enough. So this is another scenario whereby pressure still not low enough, manage to hit Mach 1 here, accelerate, suddenly shock wave, decelerate. All this will be done if you go uni. Okay, so actually this is a uni graph thing. If you go uni. So I'm not going to spend time explaining this. Okay, so your syllabus only deal with the green color graph. Okay? So if you deal with this industry, you will need to know all this. Okay? If you don't deal, then obviously just for our syllabus, just know this one. Okay now? Alright, so basically what I need you to know is this one. Is it in your book?
Yes.
Can you highlight it to a star? Okay, highlight this one down. This is the key one. This one is everything that you're going to do later.
You right here already. Right here already. Memory jam already.
Mr. One message me, sir.
What
Mr.
is
One
it?
message me. Then he delete the message, so I don't know. Hey, highlight it. Okay, so this one must know. Later we go and talk about it a lot. This one is very important. Okay. So this is just a computer simulation of the speed inside when there's a issue. So you can see what happens. Blue color means slow speed, right? Goes in, you accelerate, right? Accelerate, then suddenly, because the pressure at the back not low enough, sudden shock wave here, it suddenly decelerate. Okay, so this is not what you want. You want totally here all green color. There's acceleration too. Alright? Okay, so this one computer simulation, blah blah blah. Okay, first equation. Do you see this in your notes? Yes?
Have lah.
Have or don't have?
Have lah.
Okay, can you highlight it? Okay, I'll explain it in a while. Okay, highlight this one important. I'll use it later. So just to take note, usually your K is 1.3. Just put a star at 1.3. Okay, we seldom will use 1.1351. Alright, because for the scenarios we give you, usually inlet is super inlet. Okay, so I just want to take note the notation we use. Inlet is 0.1, throat, point C. Here is point 2. Throat is called C simply because it's actually known as a critical condition. Location with the smallest area, where mark equals to 1. So when you have design condition, your mark number is 1. That's the key part here. So here is, when we do the paper at the time, here is always assume mark 1. Alright, so highlight it. So what is DC? Throat what? P is what? Pressure. Throat pressure over inlet pressure. Okay? Equals to this equation, the K is your steam index. Alright, so there are three equations to take note. So I won't talk too much. Alright, so we'll be doing one question that's isentropic. Still remember what's isentropic? Mr. Wan teach you or not? Not Mr. Wan. Dr. Chu teach you or not?
Polytropic kan?
Mr. Wan. Hey, Mr. Wan teach you where? Yeah.
Isentropic.
Wait, did chapter 1 finish or not?
Yeah.
Have you start chapter 2?
Yeah.
Oh, that was isentropic.
Polytropic kan? Polytropic or?
Polytropic and isotropic is different.
If you teach chapter 2, you should learn entropy, yes, good.
Entropy.
Means constant what?
Entropy.
Constant what?
Isotropic.
Constant?
Entropy.
S. Do you know what you constant is? S. Constant entropy is constant S, means entropy never change. What's entropy? So this one important, I told you already. Okay? Next equation, only use where? So I strongly advise you at this one, only use at which point? Point C. I can tell you 100% of time, will give you point P1. You will need to figure out DC using this equation. Okay? Next. See this equation before? See this equation before? Okay, now mind, you also never see before, right? Anything over first, right? Ask me over power only. Right? See before, right?
Constant entropy.
Sure, right? Mass flow rate equals to what? Only one row. So, this one you learned before, right? So what we did is that the density equals to what? Remember? I asked you to find in your, remember the steam, the heat exchanger? We told you to find all the property, right? Then one of it in the steam table is this D, right? Then I told you to find your density, what do you do? 1 over density. Right? Remember or not? So what I'm saying is density is actually equal to 1 over. Yeah, right. So that means down here actually this is over what? V, yeah. So actually down here this is C A over V, where V is what? V is what? You just read Y, right? Typo, no, isn't it? What is it? What is this? Volume. Specific volume. Typo, You see all blur, right? You really say here volume. This is volume. C is velocity, right? This is what? Volume. Can you highlight it or whatever? Then make sure you know, I'm finishing already, in terms of theory. Done or not? Okay?
Sir,
yes.
Specific volume or volume?
In this case, it's supposed to be specific volume. Specific volume, yeah.
Small p.
Very small, yeah. Okay, then never mind. Later I show you where to get to. Can I continue? Yes? Yes. This equation can be used as C or 2. Alright, why cannot use that one? Actually, there's a reason why. By right, is the mass going through here, and here the same? What go in? Mass? So one go in, what go in must come out means if the mass here is the same as here, this is also the same. But the issue is, to derive these equations here, what they assumed was velocity here is very, very, very small. I repeat, here the velocity is assumed to be very small, means close to 0. When it's close to 0 here, assumption, your C becomes 0. What happens to your mass? Zero. Correct or wrong? Correct or wrong?
Wrong.
Correct in terms of zero here, zero lah.
Yes.
But does this hold here? No. No, because you know there's actually mass going through. But because of the assumption you say that zero, you calculate here, mass will become zero. Means it's not valid for the first inlet. You only can be valid for the throat and outlet. So I'm stressing this part here. But is the mass here, if you calculate the mass here, is it equal to the mass at the inlet? Yes or no? Yes, because mass in flowing throughout is equal to the mass going in. Understand what I'm saying? Sure? Now the break only dinner time. I know. Listen, last equation. C. H1 minus HC. If I want to find C, what is C?
Velocity.
Velocity. If I want to find C at point C, will be CC equals to H1 minus H C. Clear enough? If I want to find C2, H1 minus H 2 M. So now you're going to see. If let's say this C is C1, means H1 minus H1, which means the C automatically becomes
C1.
I repeat again. If C1, H1 minus okay. C is C, H1 minus H, C. If it's H, if it's C1, H1 minus H, 1. Then obviously if H1 minus H1 get what? If it's H1 minus H1, obviously it becomes 0. That's why it's not valid for here. Okay, that's what I'm trying to say. Okay, so this equation I think can only be used where? C and 2 only cannot use here. Can or not? Any question? Can or not? Yes. Okay? So I just want to stress this part here. Alright? So we just said that's all I have for theory part. Okay? Go makan. Try to come back by half an hour, because I need to cover 2 questions. If not, later you all complain that I let you off at 10:30. So try to come by. What time is it now? Okay, try to come back by 7:55. 7:55, What time? 7:55. Okay? It's effectively 2 questions out of the window. Clear so far? Okay, so now look and right at the top here, you see right at the top, all the words standing straight right okay, on the top here, right at the top, the 5.3 all the way to 7.6. Do you see the top row? At the bottom here, do you see the same numbers? 5.3 to 7.6. These are your specific entropy. So do you see specific entropy at the bottom level? So all these 5.3 to 7.6 is your S property, entropy. All clear? Follow, no follow? Follow, so you are given top and bottom, they mean the same thing. At the side here, left side, do you see 3450 all the way to 2000? Same thing, do you see at the right side here? 3450 to 2000? This is what? Enthalpy. So effectively, this diagram here is a HS diagram. Enthalpy versus entropy. Are we clear? So how do you read entropy and enthalpy? They are read horizontally and vertically. Are we clear? So you want to find your entropy is go horizontal and vertical up. Enthalpy is horizontally over. Are we clear? Don't go up, don't go down. Horizontal and vertical. All clear? Follow Next. Below the 5.3 and 7.6, do you see a series of slanted lines or slanted numbers? Starting from 1000 all the way to 14. Can you see now? Alright, the top here, 1000 to 14. Then from 14 all the way down to 0.1. 0.01, yes. Then after that, no more already. Then from 0.01 down the bottom now, 0.01 all the way to 2. See or not? All these values are from top, down, side. All are slanted, am I right? All these are what lines? Constant pressure lines. So you need to label, put there pressure. So 3 side pressure. Key thing here, they are slanted. Why do you think they are slanted? They follow the gradient of the line. As I told you, I repeat. This is enthalpy, right? Enthalpy horizontal, right? All this pressure line follow the gradient, they actually slope this way. Follow or not follow? They all slope this way. Clear? So follow the gradient of the line. Later I can confirm plus chop. People will try to read pressure vertical line. Confirm. So I want you first. Pressure how to read? Follow the gradient slanted. Follow the gradient of the number. Understand? Okay, vertical is what? Entropy. Horizontal, enthalpy. Slope this way. Follow the gradient of the line. Pressure. Constant pressure. Okay? Next. Do you see a constant temperature inside?
Yes.
So notice the gradient of the line. How does constant temperature look like? This way, So follow this. This is how it looks like. So all this here, this is your constant temperature line. Do you see 300?
Yes.
So do you see 400?
Yes.
300 here. Do you see 400?
Yes.
How many? What is the interval in between each line? 20.
10, sir.
Look, how many?
10.
10. Which means starting from down here, 300, 10, 20, 30, 40, all the way to 90, 390, 400. Are we clear?
Huh?
So every single interval here for temperature is 10. Who lost already? Okay, temperature.
Where is the 10? Cannot see.
Okay, go on. Next. Do you see the saturation line? Saturation line, how can you see? Saturation line tells you x equals to what? What is x? Dryness fraction. Means what? How dry the steam is. If x equals to 1 means it's very, very, very dry. If x equals 0, wet, fully liquid. Clear? So this means that this line here, x equals to, here is what state? Superheated, saturated. This is your partition. Clear or not? Anything on top, superheated, anything below, saturated. So can you see the constant dryness lines?
Yes.
Constant dryness, do you see?
Yes.
So starting from 0.9, right? What's the interval to reach 1? This is 0.9, right? Then what's the next line? There are 5 lines here. So what is this interval? 0.02. Clear up? So it's 0.9, 0.92, 94, 96, 98. Then you hit 1. Are we clear? Who cannot see that?
Cannot see. I cannot see.
Cannot see. Constant dryness, right? So 0.9, right? Then these are the intervals, right?
Oh, okay.
So it's 92, 94, 96, 98, 1. Here, 9, 92, 94. Like that. There's no number here. The number here is pressure. Cannot?
Oh, yeah. See that.
Yes.
Very messy. But the thing is, you realize if you want to use this, right, it's not faster than steam table. Honestly, if you want to use steam table, I don't stop you.
Okay.
But your interpolation skill better be up there. Sorry? Aggregation. Even my solution will also be agar. No need to be accurate. No need to be super accurate. But you need to be ballpark there. I am flexible with it, plus minus 10. Okay? So I'm giving you the flexibility. You hope like you hope is plus 10 and no minus 10. Okay, so okay, because later when we run through, I will be asking you to read it again. Okay, so with that, alright, can you take a look at question 1? We do easy one first. That's why I said I need to do question today. Question 1 is your easy one. Okay? Then when I go to the second question, I will be the actual one, the ideal one, the exam standard one. Okay, another thing I need to take note is, can you please type, put a star or highlight this equation at the top here? Okay, it's given in exam anyway. This highlight is so that you remember the equation here. On top. Tutorial question on top. Tutorial question on top there. I'll talk about it later. Okay? This highlight. Okay, so ready? Are we ready to start? Yes, okay, question 1. Superintestine, 25 bar, 400, expands isotropically to the back pressure of 0.5. Calculate the velocities at the throat and exit, and so forth. So, what I recommend you do, draw out the compression diversion nozzle, label. Inlet for what? Point what? Alright, so this is basically your nozzle. And point 1, what do you know? Pressure how much? Good, 25 bar. Then what is the temperature? 400. Okay. Okay, and what they also give you is your throat area. Or throat what? Throat diameter, sorry. So they give you your throat diameter. 40. Yeah, convert to meter. Okay, so they ask you to find the velocity at the steam or what? Velocity of steam at the throat means you find C. C, right? You also need to find what? Unknown. Then they also ask you to find the exit area. And the S4 rate. Good. Okay, so basically these are the few things that we find. So we'll find it in order because this is a simple question, so we're supposed to just give you understanding. So it's for priority. Okay, then we find after that. Okay, so you understand what something first. Okay, so this is what question is. Am I okay? Can I start? Can I? Okay, so this means the steam go in 25 bar 400. Usually down here, what's the velocity? I keep telling you? 0. Close to 0. C1 is actually close to 0. Always the case. Approximately 0. In real life, it's not 0 lah. Okay, it's just very slow. Alright. So it goes in. it should accelerate, so your speed here should be high. The speed here should even be higher. Always getting higher and higher speed. Faster and faster. Area here obviously must be the smallest. Area here must be the biggest. Okay, so this is what you must know. So to start off, basically, what you need to do first is you need to one more pressure never put. When pressure is how much? 0.5 bar. Okay, so this is actually this up. So you go pressure 35 going here. Pressure should get higher or lower? Lower and lower. This is the lowest. Which means that your pressure here should be the in between these two. Right now. Follow on. So if you remember the steam chart, it's a HS. So this is basically your mini map, your players, your legend, whatever. Because the mini map at the side there, right? Yeah. So this is what your saturation line. Okay? So I'm drawing this for the simplified version. So it goes through isentropically, means what? If it goes through isentropically, means what? How should the graph look like? Isentropic means what? Constant what?
Entropy.
Constant entropy means constant?
Yes.
Which means how should the graph look like? Vertical straight, clear enough? Which means your line should look like that. Here is 1, here is C, here is 2. When you draw it later here, it will be 1, C, 2, like that. Clear enough? Okay? Follow, no follow? It's because it's what? Isentropic. Do you see the word isentropic here? Can you highlight it? Okay, can you highlight? So, do you know what's the meaning? Means S1, SC and S2 are the same lah. Constant isentropic means what? Constant entropy. Constant S. Constant S. Follow or follow? You can. This one is supposed to be Mr. One. Talk about independently, you also do get it. Okay, start. Continue. So understand this one is vertical later. Okay, so the first step, number 1. Find what? Find all the pressure. So same thing when you're investigating time. Find all the pressure. Got pressure now? P1 center already. So must find what? BC. How to find BC? Did I ask you to highlight 3 formulas? So what's the first one? PC over P1 equals to
2 over K plus 1.
2 over
K plus 1.
Then
K over K minus 1.
clear or not? My question now, for P1 or not? Someone have? K assumed to be what? Even question right already, all the K here equals to 1.3. Are you able to find PC? Yes. Okay, 2 minutes. Okay, so put it 1.3, 1.3. So then this is your 25 bar. It's right there, your PC. By right you should use Tosca, but by then because here is bar, you can solve. bar. Sorry? Okay, good. Okay, 13.6 something, yeah. Sure, we get it now.
25. Put it in front. You put like that better. Like, you remove your 25 first. Remove the 25. Okay.
Oh.
Don't you?
Oh, here.
Okay, how? Any issue? Calculator in here only, should be quite easy, Okay, so can I go on? So this one should not be a problem, 30.6 something, okay? Keep that in mind. Because right now what you need to do is need to find all the hits. So actually what the question is like, what is the first part of the question is like?
Exit. Throat and exit.
No, the first part of it. Ask to find what?
Velocity.
Velocity, right? Now, do you remember what the equation for velocity? C2 equals to what? Square root 2,
H1.
correct? H2, right? And then CC? Good. Okay, now? Okay, you all know this, Now, the key thing here to take note is what? You need what? All the H, right? And where is the H going to come from? Yeah. So this is where this thing comes in already, So that's why actually part 2, okay, what you do is find all the H. So, like I say, how many properties over this?
2.
2. When you look at your first guy here, got 2 So your 2 is, are you in business? Can you open?
Yes.
So, look to find H1, what you need is 25 bar, 400 degrees C. You need this value. So I'm going to hold your hand now. Where is your 400 degrees C first? 400 degrees C, all can see, this line here. Okay, so your 400 degrees line is there. Now, where is your 35 bar? 35 bar is at the top here, am I right? Notice 35 bar. Make sure you follow the slant of the line. Remember, the number is slanted, correct? So follow the same gradient as the number, the line go down. 25 bar, the line, your intercept 400 degrees C. Mark a point there, that's a point 1. With that, go horizontally across, you should be able to see your enthalpy value. How much? 3 2 how much? 6 0.
Lower.
Listen, you see my value on the board? See I give you plus minus 10. You give me 3230 or 3250. Acceptable. Okay, so you should get this one plus minus 10. So don't keep asking me, don't keep asking me your answer correct or not like this. Just automatically plus minus 10. If you are in the ballpark figure of plus minus 10 of the value I write up here, it's fine. Do you understand me? Thank you. So can you check, make sure you can get this value. Cannot get means I need to help you. Check it out lah. Cannot get, you must sound off really. Don't wait until end of the day you still don't know how to use. That's it, I need to do now.
This one. 3240.
I get 3-5.
This one. You doing? What are you doing? Four? You looking for which one?
No, I'm checking.
Oh.
Okay,
Yeah.
so this is the first step. Okay, if you understand roughly what's going on when I go down here, it's more or less going to be. Reading this graph on the exam day should take you no more than 5 minutes for the values you need. Okay? Can or not? So you label point 1 or not? Don't make sure you label, then there should have a point 1 there. Okay, put a little cross there, point 1. You need that point 1 to continue. Okay, don't just read the value and then your paper clean one. Cannot? May I go on? Go on. Okay, okay. Point 2, point C. What do you know?
Pressure.
You already know pressure, but what's the second clue you have? It's a straight line because it's what? Isentropic. Say after me, isentropic.
Entropy.
Say again. Hey, remember the word, you have to know, right? So isentropic, constant, entropy. These words you must know. So constant entropy, constant S, vertical line. So this means that, what do you do here? Take a ruler from your point 1 that you just mark, right? Oh, you got mark, point 1, you see value, right?
8.64 bar.
Take a ruler, draw a long line. Just draw a long one. Because your point 2 also need. So just draw from point 1 there, take a ruler, draw a vertical long line down. If you are those partial one or parallax error one, you draw line slant, let's see here. Vertical line, please. Vertical.
Hopefully.
Vertical. You don't draw slowly slant. You check and make sure you draw it vertical. Okay, so from point 1, draw a vertical line down. Then what do you do next? You know that it is what? 13.64 or 65 depending on your number. So what do you do here? So look, you see 14, right? Okay, you see 12, right? You can get it in the center, up to you. That means now what I'm telling you is just agar this as accurately as possible, as much as you can. Clear? So actually what you can do is that between 12 and 14, right? You try to take 1/4 of it. Because if it's half means what? Vertical line, you draw first. So you look here, you draw vertical line now, right? This is your point 1, right? This is your point C. Then what happens? You know you got your pressure line right now. This is 14. Then you got another one is what? 12. So now you agak, you just try to agak one line. Okay, this will follow through. Maybe you want to use 13. Okay, also can. But if you obviously if you use between 13 is the center, right? If you use here, it will be more accurate, right? Yes. Because this is 13.5, right? So try to use 13.5. Okay, so you just agak like that. Just follow like that, go through. So you can split the line here into 4 parts.
Huh?
Just use your skill set, your common sense, how to get as accurate as possible. It's not nothing to give.
This one go down here.
Accurate, you are. Plus understand?
Sir, you my eyes blank already.
Sorry?
No, you need to draw.
I use computer.
You need to draw.
So that's why my one is combined accurate. You all will adapt for my relevance.
So for example here, 13.
13 here.
Yeah.
So in between these two, these two,
This one.
that's why slant.
You follow this.
Yeah, that's why. Must slant one. Follow back the value here, like that. Slant down. So this agak in between here, like that.
Until
Cut only, cut this line.
until this line.
Because you need to get this line
Cut
first.
this line.
Cut this line.
Huh?
Follow the gradient.
3250. You want 3070. How come you get 3070 itself?
Don't need to be 370.
No, where you get 3070? You from there? Until touch the line, right? This line, right? 25. Okay, go down until 25, huh? Here, 25. For example, you take 13, go down, you touch until here, huh? This line, right? You take down. Sir,
No, you touch this line.
huh?
You touch here.
Why
Somewhere
touch here?
You slant her. Slant.
Slide.
Touch here.
Until 300. Until where, sir?
Aggravation. Slant.
No, I mean, you want to
Slant
touch which
until
line?
you touch this.
No, you want which
This
line?
25 hit the 400 straight down, right? Then you from 13 point something, you slant like get
Okay,
somewhere.
this is the 25 touch here, correct?
No?
25 400, correct? The first one.
No! It's a slant line, brother. 25 is the third. Hello? Hello?
Okay.
Are you in there?
And then, oh, okay, I go there. But you see draw straight line.
Straight line is because he 25
Also-
hit 400 straight line.
Also, I mean here, 100.
You
Here,
hit 400 you straight line.
30.
Okay, so now,
30.
obviously the last part is what?
40.
Why confused?
H2. What's the pressure? So same thing. You still are dropping, Now here, all you can do is find for your 0.5 bar. Cut your vertical line. Then get your value. Wow, cut some more. Cut one more because you got 3. 1, 2, 3. 2, 4. Okay, 2, 4, 3, 5, 5. I get 2, 4, 4, 0. So plus minus 10, Okay, so plus minus 10. cut this line. You cut at this number. So look for your pressure at 0.5 bar. Pressure 0.5 bar, 0.5 bar, cut again. Same thing as how you did earlier for 13. Okay? Okay, now?
H2 is...
Can I?
Not yet, not yet. H2?
Now just now you're 25 this one, right? Yes, correct. Okay, that one hit already, right? That one is your HRC, right? So you draw all the way down until you reach 0.5, right? 0.5. That's your blood pressure, ma. No, it's a slot. It's okay. You just need to extend this one.
Okay, give you 2 more minutes. Any issue, please raise your hand.
So you 0.5 you cut through. So it's here, then you go straight.
Okay.
So you can find
2.40.
but heating here is all in kilojoule. When you put into equation, must be in joule. Because equation 1 must be less unit. All must convert to joule. Okay, first, I want to settle this thing first. Stage 2. Anyone problem? No, anyone problem, then I check your room now before I continue. Okay, because this part here, I need you all to make sure you all are comfortable already. Because this one is not the difficult part. Okay, the more difficult. So, okay, I presume no one saw anything settle. Okay, so the next part, obviously to answer your question, we will find CC and C2. So, just to be aware here, okay, I'm going to say it once. I'll repeat it when I do the next question also. Alright? All the units here must be what? What's the unit here?
Kilojoule.
Here must be?
Joule.
Here is what? You don't laugh now. Later, I saw people give me rubbish one. Okay, so this piece here must be joule. So when you put in here, your speed must be how many digits? 4, 3, 2, 4. If you go and key here and you get 80 meters per second, do you panic? You better be alert. If it's 18 meters per second, that is nowhere near supersonic. Follow or not? Yes. It must be 3 digits or 4 digits. If you use kilojoule, you will get 2 digits. I assure you. Okay? So you must use joule. So with that said, can you calculate these two? And then C2. Yeah, correct. Ah, what? C2 1 Oh, too fast. On the ball as somebody. Yeah. Use by your own value, so you will get about 126 something point something. Some of you will get 127 something alone. Because your H value different. CC is 5 something. 58 or 59, depending on your use by your own value. Okay, so you can see by this for this question, I'm not actually looking at answers. I'm looking at your steps because your answer will all be different. Okay? So don't worry so much about the answer. You do this question, I need you to be more aware of what you are typing into your computer and what formula you're using. Yes.
3 the answer. Okay, what? Sir, sir, no you can 43. Agak-agak.
Begini ya. Kita masuk ya. Okay, some of you get 35, 39, some of you get 600. It's okay, huh? Okay. As long as you are 3 digit and your number is 5 something or 6, or close to this ballpark figure around there. Can or not? Yes. How far is 5?
Why cannot get answer? You are. I know, I started with that also. And then I realized, it's slanted. What is it? Must cut, ma? I'm like, oh yeah, must slant. Don't worry, when you forget, you look back here.
Okay, one more minute, yeah. Then I need to continue, If not, you all are going to stand the time. And good equals to A over B. Okay, so here, if you want to find the mass first, okay, I just tell you, let's find mass first. To find the mass first, you want to find the mass which you need C, A, and B, right? You know more of point 2 or you know more of point C? You find this.
C.
You know more of point C. Why? Because you got CC already, right? Yes. Then DC. You also got diameter. Diameter will give you what? A. Clear so far? Alright, here you don't have A. You can't find anything, so you can't find your M. Alright, so obviously in this case, you're going to use point C to do your work. Alright, so point C, okay, so this means I'm going to use CC, AC, and BC. Okay, because you got most of the thing. CC value have or not? Have. So this one is settled already. Clear? Next, A. Haven't find. How to find? 5 R square of 5 B square over 4, where your D is diameter 0.04 meter. All clear? Okay, so this one no issue. Found already. So Now I want to talk about this fella here. Okay, so look here, BC. Do you see this formula on top here? Yes? You see this formula here? The issue is what? When you look at this table here, does it give you volume? Did I mention anything about volume when we look at this? No, So your volume actually, if you're going to use a mathematical equation to find, which is this one. Clear? Now, this formula here is basically a mathematics version of a steam table. If you look at this formula here, what are the two inputs you need? You need enthalpy, you need pressure. Two property, right? Then immediately using this formula, you can get your volume. Right? Makes sense, Key thing here, when you look at this, when you look at the statement on top, it's only meant for superheated or saturated. This formula is only used when you have superheated state. If it's saturated, can you use this formula? No, so this one on the stress. Can you take a red color pen or what? Circle the word superheated down there and put star on it. Okay, so do not ever use this equation when you are dealing with saturated. Clear? So with that said, point C, saturated or superheated? How do you deduce that? How do you figure that out? How do you know that your C is superheated? How do you tell it's superheated? It's above your point C. Or you check your point C. Is it above your saturation line? Yes. That's why it's superheated. If your point C was below your saturation line, means it's wet or saturated. Are we clear? Follow it's based on the point. Where is it on the steam chart? Clear? So in this case, when you check your steam chart, point C is superheated. And therefore you can use BC equals to what? 2.3. Say 2.308. Bracket minus H minus 194.3. So this HT bracket
over 10 power of
10 power 3 times PC. Great, thank you. Okay, so HC, PC. HC, based on the formula there, what do you need? 3070 kilojoule per kg. Follow the units on the equation. What the equation tell you what you need to put there? Kilojoule. So don't X mark like this. Here you say joule, yes, what extra you need. But this equation already tell you must use here. You must use kilojoule. This pressure here, what you need? Bar. Insisted by the equation already. So don't go and change it. Don't go and change Pascal. Equation here already say they want bar. Equation say clear now? So do anyhow change. So with that, can you calculate your BC? Get your AC. You have your CC already. Straight away, can you find M? Can you find M or not? So what is, okay, some of you confused already. Find this one first. Then find this one. Then you solve this one.
What's the PC? Where's the
Okay, step by step. about there, depending on your. Try to give you more something. Sorry? For C you must use Joe because these are all SI units. This is a SI unit equation. While this one is already a configured one.
C you need to convert.
You need to convert. Convert who? Something or 3.9 something, okay? Your aim, that's your one. Okay. 3.9, 3.8. Okay, so what you can notice is that the formulas here are actually not difficult to manipulate. The formulas itself are actually very simple. It's just when to use it and where to use it.
Good.
Yeah.
This one is pressure as well.
Yes. All this is pressure, what? Just now you say.
It's not 1000.
Yes. 0.01. Then here also all these are pressure.
So what is pressure?
This one is not.
This one
All the slanted is pressure.
Then this one is
This one is
entropy.
This one is enthalpy.
So pressure is more. Huh?
You see what?
Next semester.
So, is it next semester now?
Yeah.
No. This one bar also, right?
Yeah.
This one bar. How come I missed
Okay,
it?
and
Have you given me a skill?
so with this
Do
done,
already.
This one.
Do already.
then you need to find A. Okay, so the last part is to find A. Do you use that as a equation?
Yes.
Wow, what expert here. So this is a mess. Obviously, if you find A2, this will be C1. D? Clear? Okay, so everything put to here. So C2 here now. Target is to find this, right? Now, this fella here. Okay, not bad, this fella here. No or no?
No.
Same, huh? This is same as this guy, huh? Match found already. So now comes my V2. So you take a look at V2 here. Check your chart, huh? Super saturated.
Saturated.
Can use? No. Cannot. So, based on what Dr. Chu or Mr. Wan teach you, Dr. Chu teach you what? one is how to find it saturated.
Take the bar.
Same before. Okay. V2 equals to XVG. What is X? Because X come from where?
Saturation.
Screenshot. About 0.9 something. Should be around 0.92. Okay? Please be sure to check if you get that. Yes, constant dryness 9. Okay, and then your VG gets from where?
Volume.
Stable. What pressure?
0.5. How you get 0.2?
9-1, sir. 9-1.
Thank you.
How you get 9.1 also?
Where's the point? 9? You got 9? 92, right? Center, right? Done.
Three point two four one. 3.241.
The VG gets from 0.2.
So V is volume.
Yeah, specific volume.
What's your V? What's your V? What's your unit?
M3.
Per kg? Small or big?
See the VC per kg.
VC? That's all VC. Where you get VC?
VC is just now the one
Oh, yeah.
is M3 per kg.
Specific volume.
Because this is specific volume.
How do you know it is specific?
This specific volume. Yeah, they're using specific volume. Can or not? The faster we finish this one, the faster I can go next question. Yeah, I know, I give you a line. Question? About 9,000. No.
0.
About 9,000. 9. Got me.
Yes. Nothing wrong.
They are 8.97 something times 10 power and 3. You get about that? You get some of you will get 9,000, 9 point something.
I guess I do something.
10. Okay, so we show you copy all these things already. Simple thing almost is very loud. Just easy. Okay, you copy all these things already. This one is not issue.
How do you think you want to outside?
Okay, anyone need help? Kancang ni. Okay. Supposed to be M dot V2 over C.
What? A2.
No one.
This one is A2.
Yeah.
Why is it smaller than C?
So this diameter. Area will be right here.
No, sir. I don't want some. Like that will feel
Okay, that's right. Don't you have finished? It's fine. Just take down the stuff first, take photo or what. Okay, so after class, okay, I will help you settle. Okay, so we do the question first.
Yes.
Set up?
Yes.
Okay, so with that, let's take a look at question. Why two number? Okay, let's do question 3 lah. Okay, actually if you know how to do question 3, the rest of it is really more or less similar. Okay, so I'm going to start with this part. Let's do it 1. Okay, this one I give you first, I'm going to do it. Okay, ready? So we're doing question 3, So how can you tell question 3? Okay, so this is MST standard, this is EST standard area. Okay, so take note now there will be slight differences. Of course, there will be slightly more added things inside. So, superheated steam at 20 bar, 290 extends to a convergent divergent nozzle, same nozzle. Okay, discharge pressure 1.6 bar. So you go here, E1 is what? 20 bar. T2, 91. 290, thank you. Then extend to P2 equals to 2.6 or 1.6. Okay, so you know this pressure here, you know this pressure here. Okay, then next one is given. Okay, so now is what I need to take note. I'm going to write in red. Real life. Now, when you have ideal case, your nozzle is isentropic, right? Ideal, ideal. No friction, no heat loss. But when you got friction, you got heat loss. What happened to entropy? Mr. Wan issue. Your entropy will change. Your entropy will increase or decrease. Whenever you got issues like friction will decrease. What is the issue? Entropy must always. What are the issue for entropy? What is the issue? Okay, so no friction, yes.
You only say there's no friction
So,
in the top.
when no friction, okay, so when there is, okay, so you say no friction. So when there is friction, what happens to entropy? Entropy will increase. Okay? Because based on the concept of entropy is actually the second law, it states that the system is isolated. What does isolated mean? Closed means what? Closed. We do look at now, big one. Closed means what? Closed system means what?
Within the boundary.
Whenever in thermo, you're always dealing with the system. We always target two things only. Got energy or not? Got mass or not? Energy is your heat and work. And then the other one is your mass, whether got mass flow. Closed means what?
All within.
Got energy. Means you got Q, you got W. But you got mass
No.
Mass no. Open means what? Got mass, got energy or work or heat. So for thermo 2, what is isolated mean?
Close.
No. Energy. Mass have or not? Isolated means both don't have. nothing. The thing is just standing there like Tupperware. Right? No gas going in, no heat and work going out. Clear? So when it's isolated, what happens to entropy? Okay, so let's say if you have something in some center, here is water, okay, here is water, here is Rabina. Okay, water, Rabina, partition. When you remove this partition, what happens? Rabina and water mix, right? Entropy, the word here entropy is actually the measure of the disorder inside. That means how messy it is. In layman terms, how messy it is. If you have a partition there, one side water, one side Rabina, is it neat? Neat, orderly. Entropy is actually lower. When you remove the partition, the two mix, right? Orderly or messy now? Messy. When it's messy, when you measure the entropy increase or decrease? Increase. Okay? So things that make things messy are like your friction, your heat loss. This means what? When you got friction, you got heat loss. Entropy will increase. Always increase. Ideal case will be no change. If not, it will increase. This is the meaning of entropy. Understand now? So when in this case, if I say the nozzle got friction, got heat loss, means your entropy will increase. Only can increase. This means that actually your actual curve look like that. What is C prime and 2 prime? The actual C and the actual 2. What? You remember my name. So, 1 C prime, 2 prime. Okay? So this is actually the one with friction on it will actually look like that, here to the left. The one no friction on it will be straight. So right now in this case, what it actually tell you when you go on is telling you that actually the friction on it is going to veer to the right. So listen up. This means that by right, C will become C prime, 2 will become 2 prime. Clear now? This means that the properties here and the properties here are actually slightly different because they veer to the right. But to make your life easier, what we did was notice the difference between the C and C prime. Very small, correct? Whereas the 2 is bigger, right? So what we do is we make our life easier. We assume 1 to C. We just take it as ideal. We only bother about. So we only have 1 additional point now instead of 2 additional points. Are we clear? So for your EST, this is the thing that's going on. You need to look at 1 C and 2 and 2 prime. Okay, so this is important. Okay, so initially my question earlier I did what? 1C2, right? Now we got 1C, 2 prime. Okay, 1C2 and 2 prime. Total additional point up, 4 point out. Clear now? Okay? Follow up? When the flow goes through the nozzle, without friction or with friction, the mass flow is higher. Now you got one with friction, one without friction, right? Yes. Mass flow rate for the friction one and the non-friction one, will it be the same? No. Obviously not. Which one higher?
Friction.
No friction will be higher. Are we clear now? You got something flowing through a pipe. If the pipe has no friction, same condition, pressure in and out, obviously more flow will go through the no friction one, which is the ideal one. All clear now? Follow up. This means that when you look at the mass flow here, what's the mass flow given here? 14, huh? Question? If? Question? Ask. Always ask for actual. Means right now, you notice you got one ideal, one actual, right? Ideal is your isotropic one, actual is your real one, right? Question ask for something, question give something in your question, always asking for actual. Which means right now, your mass here, what mass is it? Actual mass, huh? And prime. All the prime here, the prime here is actual. So this will take note, anything with n dot prime, or in this case 2 prime, these are all what? Okay, Mr. 1 is going to issue into 1. Anything we put, so that is prime. Huh? Okay, so question ask, question give. So what we have now, this one n dot is prime, it's actually 14 kg. This is actual. Okay, as we go on, our elaborate this, we put that there first. So, they say the inlet is negligible again, same thing. And then they tell you that the coefficient of discharge, so got two new things here. Coefficient of discharge is 0.95, efficiency is 0.9. So whenever, can you take a highlighter and highlight coefficient of discharge and nozzle efficiency? Okay, I'll talk about this later. Coefficient of discharge is 0.95, nozzle efficiency is 0.9. Okay, there's actually a formula for this. I'll just write aside first, we will deal with it later. Okay, this is how you deal with your discharge efficiency, m dot prime over m dot. Nozzle efficiency equals to, this one also I cannot remember. So you got another one here, nozzle, this is CD. Okay, so this is your coefficient of velocity, coefficient of discharge. Okay? Okay?
Coefficient of what?
Coefficient of discharge, coefficient of velocity, which comes from your nozzle efficiency. Okay, you just write it down first. I will deal with it when we use it. Okay. Okay, and that's all the question gives. Next, nozzle. Efficiency nozzle. Nozzle efficiency. Okay, so can I continue first? Okay. So take note, this one and this one. Okay, and this one, these three. Additional thing. This is a slightly additional thing. Okay, so we got now an actual point here. So we go actual point here. Okay, so when I explain later, I'll be talking a lot about ideal. This is the real life area. No more the question 1 GB state. Question 1, fundamental, hopefully you all are stable here. Okay, can I continue? Okay, so listen steps for the first part, still the same one. So this means what? In EST, if you cannot do what I'm going to do here, very minimum we have to do the first part. Right now. Although I don't know how many of you are still saying that you first part, some still cannot do it. At least you do it already. So listen, So, 1 C show. Same thing again. Find what? Find all P. You got P1, you got P2, you have to figure out PC. Same step again. Can you calculate this? Now it's put again to take less than 2 minutes. Okay, I will not dwell too much on what you did before. I'm going to dwell on the differences. K is only 1.3. You always can assume 1.3. So actually, if you are observant, this value here, right, is fixed one. If it's not wrong, this whole value here is always 0.54. So you want to memorize, you can just memorize number. But that one I only give you the equation. The number you want to memorize, you memorize yourself. I think only the equation is given. He never give you the number here. So if you want to memorize, it's 0.94, 0.54, something. Because every time you calculate 1.2, 1.3, it's always the same value. You have to keep redoing this part over and over again. So closer to the assembly, do if you can memorize this number. Okay? Here give about formula list level. That's for us. 915. Okay, take. Okay, fine. Okay, this one is honestly is not the hard part. So now all still remember to do. So 5 minutes, you try. 1C2. Don't find 2 prime first, 2 prime you find last. Just find 1C2. The same thing applies. So what's the first one you know? 30 bar, 290, right? Get your first dot, find your first H. Again, draw vertical line down. Cut at 10.95, 9.15, and 1.6 bar. Okay? Run through this process now quickly. Don't ask again. Okay, so now I let you independent a bit. Remember your pressure, don't make your pressure lines horizontally. It's always pressure is always slanted. Yeah, you're right. On the dot, very good. Plus minus 10, remember, anything I read for H is all plus minus 10.
3010.
Okay, 3010 or 219, 2990 or 210. So, you get around 3000. So remember, once you get your point 1, mark it down, okay, and draw a vertical line. Okay, if you want to make the line easier, erase your O line. Okay, don't get confused. juga. Anyone else need assistance? 304. 304. Siap. Again 2865. Estimate 11 ah.
2855.
From here lah. This point here.
2860.
Page 2 ah. Two five ah. Thanks. Ini your point 1, the 25 to 90. 25 to 90. Okay, what's your point 1? Okay. Okay, then you need to draw a particular line now. What's the topic? Yeah. Draw wrong. So after that, if you use together, so in between 12 and 10, in between. Now, 11, use some now. You cut that line. Then you read to get about 2 weeks. You from this point, right? You got one point, right? Point, right? You take a ruler, you draw a long line down, right? Then you take this one, you cut the line. So you look for 11. 11 bar. 11 bar you cut. Intersect your vertical line. You should get this sequence. Okay, 2 more minutes now. almost. Now, okay, now first, all done now, isn't it? Only more line. More one, continue one. So I presume all can, Okay, so it's all this setup, please, so that means by today, next time if I ever ask you to open Steam chart, all should know how to do it, Okay, all should be okay, alright. So, this one, up to this point, this one you find. Next step, what? Find the C. Find the C, no different. So now, okay, find C. Can you try? Okay, give it 2-3 minutes, quick one.
Okay, so first I have to find, okay, first I have to find C2, right? Yeah. This one, remember I got one C and C2, right? Question, ask, question, give, asking for what? Actual. This one is ideal, actual? Ideal. Okay. You get me? Yeah. So two is ideal. So actually this is not answer. Okay. You have to go one more step to find your C2 prime. That is your. Okay. You get me? C2 prime. Yeah. That's the same. Because you see the actual is 14. Correct. Where does it come? So where does this one come from? That's why actually comes from here. I haven't touched this one. Coefficient because of this coefficient. So because coefficient of this efficiency, right, you actually know this efficiency is 0.99. Okay, you can find the CV. Because you just do square over. The CV here is equal to C2 prime over C2 ma. Okay. You already got C2 ma. Yeah. Okay, you find C2 prime ma. Then that's the answer here. It's still using this. So if not now you can try and find throw area here. Throw area here.
Those of you can continue, do try to continue. Okay, find C now. Then you can find the throw area. Throw area. Same, not equation the same, but not two lah. C. Throw area is AC, right? Right? Not AC, right? So it's actually M bar equals to CC AC over DC. The one I erased earlier. So it's this one. Then you try to find your AC. You got this one, this and this. Okay, the catch here is what? Okay, first, okay, never mind. Those of you who want to try, go ahead and try. But be prepared for it to be wrong. Because this one, there's an issue here. On top of it. This one is actual, right? But here you need to use ideal. So it comes from this formula. The actual here is 49. So here is this one, then you can find M. With this new M, you can put here.
So that means you need the CV and the M actual.
Yes, you need
you find
the M actual, but because your one to C, right, is ideal, right? You have to use the ideal one. So you take 0.95 here, 14 here, you can find M. The M is your ideal M here.
That's the ideal M.
Yes. Okay, so all can do this now. Okay, so at least that's why I say bare minimum right, exam make sure you can come at least up to all the C. Okay, so your C2 here is okay, and you get the value, and then you got your CC here. How much? 367.4 CC.
Huh?
Right, it? Then what?
538.
1,000, 1,009, yeah? Okay, now minus back. Then this one?
1,000. C2.
538.
547.
Okay, now then I put 547.
Somewhere there.
Whatever lah. I see 3 digit lah. Honestly lah, the test I see 3 digit I very happy. You know why not? Half the time people give me 2 digit man. My expectation is very low only. I see 3 digit I happy.
What is your H2? 510.
My one 3010.
Okay, okay, right. I see all confident here. Okay, so please EST. Don't know how to do here. Bare minimum. Okay, next. Question has to find what?
Mass.
Mass flow. Okay, so look here. Part A asks for what? Short area. Okay, short area. Listen, short area. Equation is what? M dot
C.
Okay. Is C over
V.
right? Okay, so formula no difference, formula the same. But this one no prime. Sorry. Okay, no prime. So look here, why no prime? 1 to C is what? Assumed to be ideal here. I told you we don't want to assume the so ideal. So because it's ideal here, remember, question give, question ask. Always what? Which means that your M is actually M prime, which is 14. But down here is what? No prime. Ideal, because ideal. So if there's no prime here, to find your M, you need to use what? CD, coefficient of discharge. Equals to your M dot prime over your M dot. CD is what? Based on question given. 0.95. This is what? 14 over your M dot. So yes, you swap, you should get this. Okay, equals to 14 point something something. Okay, understand huh? So this part is slightly new Now, if you don't know how to do this in exam, then what do you do?
Sleep.
Just do this one, put in 14. I'll still give you some mark. Clear?
You sleep no mark when
Yeah.
Except for the 2 prime.
Yes, 2 prime is the one that deviate, right? Okay? So actually, all these steps here you're doing, you're still doing as it is ideal. So what is your aim? Don't know lah. What's your CC? Have already, so this one done. Now your VC, superheated or saturated? Superheated. So, what equation?
No, not that. 2.30.
H.
H minus 194.
So HC minus 1948. 43, divided by times square. You must check that it's superheated first. Superheated. So superheated means you can use this one. Okay, so with this you calculate you got your CC, you got your VC, you got your mass from here. Found already, huh? So you just have to find your A. What? Okay, you're done. Okay, so the new thing here, the very new thing is this one. Given the velocity so much. Velocity means they ask for easy, right? Means we can find actually, right? Means we need to find one. So the front means we have to choose the nozzle, CV, and the CV is like the velocity part. Because we that's how we find once we go through the equation, then we find the ease of it. The complicated one is not Wait, there, 5 point?
Times 10 total.
5.4. Some 4, some 2 lah, right?
7.
Okay, no many. Fine. So we just put like that. Times 10 about what? What happened now? On one complaint now, I see. That's why the wonderful thing about XX. You walk what you like. That's why I said don't give me that many.
Sure.
Okay, where's the C point? Here, huh? So both the same color,
Start like velocity. Now because you use CD, so it's not the same. Just now the velocity is ideal. Now we want to use, I know, just now was actual. Now you want to use ideal. Haven't.
Okay, see, all can do or not, all stop. I'll give 2 more minutes, huh? Anyone need help? Can you get this? Yeah.
one is your this one?
That one is C2. That one is your ideal. That one is your straight line, for the straight line. Then this is straight line. Because it's C2.
You don't confuse me.
Because it's together now, C2. Because straight line now, this one.
It was
Huh? Correct or not? Because C2, yeah.
C2 is actual. This one is ideal. No,
This is
actual.
ideal.
It's ideal one. No, I'm finding ideal one.
But you don't have this one.
You have this one.
This one is ideal.
Okay, let me go on first.
Let him
Okay.
explain.
So, part B, what the question asked for? Huh? Exit velocity. Exit velocity is what? What's the symbol for exit velocity? C? 2. Yeah? Okay, Question asked, always actual. Means what?
Ideal.
Prime, huh? Question gives, question asked, always actual. Means you are looking for C2 prime. You find here is what? C2. This is your ideal one. Question 1, prime 1. Clear or no clear? Good, huh? Clear, huh? Follow, huh? I repeat one more time. What you have found here is your ideal one. Question B, question asked, always actual. Which means they want exit velocity, they want actual one, which is C2 prime. So how do you go about finding C2 prime? So look here. Question gives you nozzle efficiency 0.9. So nozzle efficiency here. Okay, so this is nozzle efficiency. This one is coefficient of velocity. Can you find this in your book? Your notes can find, huh? Okay, so you can find this fella here. CV is actually C2 prime over C2. So this nozzle is actually your 0.9, right? Can you solve for CV? Oh.
Square root.
Square root bring over become C2 0.9 square. Clear? Square root bring over 0.9 square. This means that 0.9 square equals to C2 prime over C2. Do you have C2? Yes. So you need to solve for? Done. So now you need to define only about C left. So now listen, my disclaimer is A and B is actually easy one. Like that only. Part C is the one that going to take time to understand a little bit more. If you cannot do part C in exam, don't waste time here. Do other thing. Do elsewhere. Remember, exam smart is about survival. Okay, you don't need to know everything. You just need to know enough to pass. Okay, so the two important equations, please take note of it in your book or whatever. Okay, so this one and this one, this one is the important one. Okay, so these two formulas, please make sure you know where to find it. What is going to do with it?
On one lah.
Huh?
0.92, 0.91.
Huh?
One lah, 0.92, 0.91. In the middle lah. See the this one in the middle. No? 0.91?
You just now said 0.91 eh?
91 lah. Because this one 2. I down here lah.
You closer to 2 or closer to 1?
1. This one is none. 2. So I'm in the middle. So
You're not in the middle, you must.
0.91. 0.91. 0.91. In the middle.
Are you happy can already? As long as you are happy can.
What's the bar?
Yep. So say that. For here, because question asking for prime. Asking for 2 prime. Point. No, this one. This one. This one is actual one. This is ideal one. Actual. Ideal. Question ask.
It could be different.
Question give. Always. Actual.
Don't see lah.
Yeah. Sorry? Yes, find the 2 prime. Because it is what? Check one thing very quickly.
I just wrong
Okay. Listen.
This one I
Listen ah. I salah ni ah.
This one actual.
Salah ni, salah. Okay ah. This formula, check that. On our check that. Page 5. This means this one actually square ah.
I do understand.
So the 0 point is square. So yes. So listen ah, formula is something like that ah. Square root ah, square. Okay, so
Again. Oh.
Itu dah.
Same lah. Should be square, not. So it's
Yes, about there also. Also What do you want to convert? 1, 2, 3 lah. 15. Eh? Ah no, times 6. Six up, right? Yes. Correct.
so let's replace the square with square root.
page 5. Sir. So this one, this one.
Page 5.
Jadi is the correct.
Okay, so last part. So now, those of you who can understand. Okay, I will try to go relatively okay. So listen. Okay. Final part asking you to find what? All listen now, listen. Find what? Area, exit area. Which is obviously your A. 2. Exit area. Physical dimension of a nozzle. There's no actual dimension, ideal dimension, one dimension, which is the dimension. Okay, so no A2 prime, A2 only A2. That's it. Clear the bar? Okay? So, best obviously to find this, you are going to use that is okay, so mass to find exit. Actual mass or ideal mass?
Actual.
Good, actual. Now remember everything here is dealing with the exit is actual. Equals A2 Then C2, prime or no prime?
2 prime.
Good, prime. Everything exit is always prime now. Divided by V2. Alright, that's a prime also because we're dealing with the factor. So, prime. Only area no prime because area is physical dimension. There's no such thing as ideal dimension, actual dimension. Nozzle you install is that dimension. Okay? Do you have this? What's the value? 14. Good, we should use 14. We'll use 14.7 here. Second, have this?
Yes.
Right there. Yes. So, the only one you don't have is this one.
We need to find the
So, listen, I'm going to make sure it's quite clear. Number one, you found this, am I right? On your steam chart now, do you have a 1C2? Yes. On your steam chart now, you got 1C2. Correct? You found this now, 1C2. But you don't have 2 prime. So the thing you don't have is your 2 prime point. Okay or not?
Okay.
This means that if you don't have the 2 prime point on your steam chart, do you know if this is superheated or saturated?
No.
You have no idea because it's not here. You don't know is it above or below. Which means what is your next step? You must figure out where on earth is it. Which means you have to be able to plot your 2 prime point. Okay, this one. So your job now is to find where on earth is it on the chart. You want to plot it. You want to plot it in here. So in order to plot it in here, you need 2 properties. Correct? First property you know is what? The pressure in these two is the same one. Okay? The pressure is the same one. So 2 and 2 prime, the back pressure, the pressure on the outside is always the same now, obviously, it's physical all that. So it's 1.6 bar. So you only got 1 property, am I right? Correct? Now you need to figure out one more in order to plot here. I can actually just say, okay, so go and figure out what other property you know, but let's not waste time. I tell you answer. So, the second property you can find comes from where? C2 prime. If you look at the C2 prime equation, this one, am I right? What can you find out from here if this is C2 prime? You can find H2 prime. H1 have or not?
No.
Yes. So you just have to find for H2 prime. Have this or not? So for H2 prime, right now. Do I know some of them already? No, those of you don't get it. Which part you don't get? Where is one? Okay, what's the question? H2 prime is this 2 prime point. That means if you plot your 2 prime point, you draw a line across, you should be able to find your 2 prime. But the key thing now is you don't have 2 prime point. So you are going to use your C2 prime to solve for H2 prime. Then you can find the value on your steam chart, you draw across, you cut your 1.6 bar. That's your job. That means what you're doing now. After you find your 2 prime point, okay, so 1C2, right? And then you got your this one is your 2 prime is 1.6 bar, right? Actually, you don't know where is it. So when you really know this, so once you solve for this, you get a value. You plot it on here, the same unit is here. You take a ruler, you draw across. You cut this point is your 2 prime. That is your job, actually what you do. So first find what is your H2 prime first. Once you take your H2 prime, you can plot it on your steam chart. Okay, if you don't get it, it's fine. Make sure you know how to do until what? Then this one will be blank. Do another question. So bare minimum and it's not do this. If a bit more expert do this. Fully expert go and try. Otherwise focus here or here.
So value somewhere here.
Where?
358.05.
How you sub in the C2?
So this one can. Hey, this one is good. This one is supposed to be square root of E. You get this one. You should get about 900.
Why you have 1,000?
Oh, wait. Sorry.
This one here, this one can be so small.
Okay, answer or no answer? Yeah. Okay, those cannot solve here. C2 prime equals to square root, right? How to get to a square root?
Square.
Square 2 h1 minus h2 prime. Then how to get rid of 2? Divide. So now once you divide any what happen? You do next. Switch over lah. So this one, you can bring this over here, you can bring this one over there. So become h1 minus this one equals to h2 prime. So listen all these must be what you need? Joule. Okay, now so this honestly I have to say some of you get it, some of you won't get it. I mean I understand that part. So you get it good, you don't get it, then at least not good bigger. All that.
Then the value become negative.
You should know. Positive. You calculate what positive. Check it out, do one. I get about 2, 5, 6 something. Then I'm like 2, 5, 5, 6 something. About that, 2, 5 something. So if you do this already, all 10 out.
What's the answer?
2, 5 something.
I get 3, 4.
5, 5, 9,
10.
I think you should. Minus, one minus the one.
Okay,
Here is my next. So if I bring over here,
No. Because this part here. Okay, wait. Here is minus. You bring over plus. But this part here you have to bring over. Because you bring this one over, you need to bring this one back. Because this one is only bring this one. If you never bring it over, this one is only
Get it?
Too many stuff like that. So it's negative. Huh? Negative kan? Apa? It's negative.
No, no, positive. 2559.
Two?
Positive 2559.
Plus. Negative.
Positive.
Okay, I tell you what, okay, get it. We have time. We time out today.
Negative kan?
Okay?
Sir.
Then I'll continue next week.
It's negative.
It's negative, but actually it's positive. Because you minus your minus H2 ma. So minus the left minus the right, you can cancel the minus ma. That's why you get positive. Okay, so time out first. Okay, so we get this value already. You hold your paper. Next week I will continue and finish off the question. Okay? I want to give you back your paper.